Let's find f plus g of x, which is f of x plus g of x. We get 2x plus x squared minus 4x, which is equal to x squared minus 2x. Let's find the domain of f plus g, which is the intersection of the domain of f and the domain of g. The domain of f is the domain of 2x because it is a linear function. The domain without any restriction is from negative infinity to infinity. The domain of g is the domain of x squared minus 4x because it is a quadratic function. The domain without any restriction is from negative infinity to infinity. So the domain of f plus g is from negative infinity to infinity. Let's compute f plus g of negative 1. Using the equation we found, we have negative 1 squared minus 2 times negative 1. We get 1 plus 2, which is 3. Or using the original function f and g, f plus g of negative 1 is equal to f of negative 1 plus g of negative 1. We get 2 times negative 1 plus negative 1 squared minus 4 times negative 1, which is negative 2 plus 1 plus 4, which is negative 2 plus 5, so we get 3. Let's find f minus g of x, which is equal to f of x minus g of x. So we have 2x minus x squared minus 4x. Then we have 2x minus x squared plus 4x, which is equal to negative x squared plus 6x. F minus g of x is equal to negative x squared plus 6x. Let's find the domain of f minus g, which is the intersection of the domain of f and the domain of g. The domain of f is the domain of 2x, which is negative infinity to infinity. The domain of g is the domain of x squared minus 4x, which is also negative infinity to infinity. So the domain of f minus g is from negative infinity to infinity. Let's compute f minus g of 3. Using the function we just computed, we have negative 3 squared plus 6 times 3, which is equal to negative 9 plus 18. The answer is 9. If we use the original function f and g, then we have f minus g of 3 is equal to f of 3 minus g of 3, which is 2 times 3 minus 3 squared minus 4 times 3. We get 6 minus 9 minus 12, which is 6 minus negative 3, and the answer is 9. Let's find f times h of x, which is f of x times h of x. We get 2x times square root of x minus 1. The domain of f times h is the intersection of the domain of f and the domain of h. The domain of f is again from negative infinity to infinity. The domain of H is the domain of square root of x minus 1. So x minus 1 has to be greater than or equal to 0. So x is greater than or equal to 1. So the domain of H is from the closed interval 1 to infinity. The intersection of the domain of F and the domain of H is the closed interval 1 to infinity. Let's compute f times h of 2 using the equation we found. We get 2 times 2 times square root of 2 minus 1, which is equal to 4. If we use the original function f and g, we have f times h of 2 is equal to f of 2 times h of 2, which is equal to 2 times 2 times square root of 2 minus 1. So we get 4. Let's find h over g of x, which is h of x over g of x. G of x cannot be equal to 0. We get square root of x minus 1 over x squared minus 4x. The domain of h over g is the intersection of the domain of h and the domain of g minus x values such that g of x is equal to 0. The domain of h is the closed interval 1 to infinity, and the domain of g is from negative infinity to infinity. We need to find a set of x values such that g of x is equal to 0. G of x is equal to 0. So we have x squared minus 4x is equal to 0. Then x times x minus 4 is equal to 0. So x is equal to 0 or x is equal to 4. So our set of x values is 0 and 4. Then we have closed interval 1 to infinity minus a set of 0 and 4. Because 0 is already outside of the interval from 1 to infinity, we need to exclude 4 from the interval. Then the domain of h over g is from the closed interval 1 to 4 and the union of 4 to infinity.